182. We're on number 4. This is part of section 3.4 where we are finding, or we're doing second derivative analysis, right? Second derivative analysis. All right, here we go. So we're going to take the first derivative first. So that's 4x cubed minus 12x squared. Go ahead and take the second derivative. That's 12x squared minus 24x. Go ahead and factor it. So take the 12x out. That'll be x minus 2. So that means x equals 0 and x equals 2. Make a sign chart, 0, 2. It's going to be positive, negative, positive. I'll let you do the sign chart on your own. If you need help with that, please let me know. All right, so that means it's concave up from negative infinity to 0 and from 2 to infinity. It's concave down from 0 to 2. You have points of inflection at 0 comma something and 2 comma something. Okay, so in the last example on the previous video, these boundaries were, even though concavity changed, they were not points of inflection. But this one, they are points of inflection because 0 and 2 are part of the domain. Right? That means I can plug in 0. If I plug in 0, I get 0. If I plug in 2, that's going to be 2 to the 4th minus 4 times 2 to the 3rd. So that's 16 minus 32, so it's negative 16. All right, so those are my points of inflection. And that's example 4. Let's go on to example 5, page 182. We're asked to analyze the second derivative from 0 to 2 pi of this. So it's h prime of x equals cosine x minus sine x. All I'm doing is taking the derivative and then take the second derivative. So derivative cosine is negative sine. Derivative sine is cosine. So that's that. Now we do what? Now we analyze this. So that means we set it equal to 0. When we set that equal to 0, it doesn't help much. So it's negative sine. So whenever I have a typical sine and cosine mix, right? This is where there's nothing too much about x. There's nothing too much, right? So there's nothing on the x other than the trig function. Okay, there's nothing else. So what I do is and they're different. If it were sine, another sine, then I would do something on the same side of the equal sign. But when one is sine and one is the other cosine, you split them apart. And what you're going to do is divide by one of them. And I'm going to divide by cosine x. And when I divide by cosine x, the left-hand side turns into negative tangent x. And the right side turns into 1. So now I have a regular trig equation to solve. I'm going to go ahead and move that negative sign to the right side, right? So negative tangent x equals 1, the same as tangent of x equals negative 1. So this gives me x equals 3 pi over 4 and 7 pi over 4, right? Tangent of 3 pi over 4 is negative 1. Tangent of 7 pi over 4 is negative 1. And there was a question today about do I need to add on the k pi? I do not, because I am in this interval from 0 to 2 pi. And generally speaking, I don't really need the k pi if there's nothing on the x, okay? And I'm in the closed interval, okay? Or I guess it depends on the size of the interval. In this case, I don't need it. All right, so that's it. So I'll make a sign chart. So sign chart in this case goes from 0 to 3 pi over 4 and 7 pi over 4 and 2 pi. And it ends there, right? Because that was the interval we were given. We give from 0 to 2 pi. So pick a number between 0 and 3 pi over 4, like pi over 2 fits, so pi over 2. And go back to the second derivative. We're looking at negative sine of pi over 2. So negative sine of pi over 2 minus cosine of pi over 2. So sine of pi over 2 is what? Sine of pi over 2 is 1. So it's negative 1 minus 0, so negative 1. So it's negative there. And then between 3 pi over 4 and 7 pi over 4 is 3 pi over 2. So it's negative sine of 3 pi over 2 minus cosine of 3 pi over 2. Right? So sine of 3 pi over 2 is negative 1. So that becomes positive 1. And that's 0. So it's positive. And then 7 pi over 4 and 2 pi. What number is there? This is very close to 2 pi, so I'm going to do like 11 pi over 6. So negative sine of 11 pi over 6 minus cosine of 11 pi over 6. Okay. So how did I choose that? I know that. So this is like a 45-degree angle, right? So it's like 315. So I need something like 330. And in fact, 11 pi over 6 is 330. All right. So that's going to be, what is the sine of 11 pi over 6? Oh, negative 1/2. And the cosine of 11 pi over 6 is square root of 3 over 2. So that's negative, that's positive, minus positive 1/2 minus square root of 3 over 2. So that's 1 minus square root of 3 over 2. Well, square root of 3 is bigger than 1, so that's going to be a negative value, right? So that's negative. All right, so it's negative, positive, negative. So it is concave up, only from 3 pi over 4 to 7 pi over 4. Concave down from 0 to 3 pi over 4 and 7 pi over 4 to 2 pi. All right, now what can I do with this? Oh, I need the points of inflection. My points of inflection is going to be 3 pi over 4. Plug in 3 pi over 4 and I get 0. And I'm plugging into the original function, right? Sine of 3 pi over 4 is square root of 2 over 2. Cosine of 3 pi over 4 is negative root 2 over 2. So that's 0. Plug in 7 pi over 4. Has the same effect. So it's 0 again. All right. So that's the analysis of the second derivative. Okay. Those were examples on pages 180 to 182, 1 through 5 in the Incredibles book. This is the second video of a two-part video. Okay. All right. That's it. The next group of videos is going to be looking at the first derivative and analyzing that in the context of the second derivative. All right, bye-bye.